So in the last section we learned about how to name ionic compounds, binary ionic compounds, and also we how to learn how to write ionic compounds with polyatomic ions, and also how to name acids. Okay, so in this section we're going to learn how to name binary molecular compounds. In other words, molecular compounds are the covalent compounds. Covalent compounds are formed between nonmetals, and you know where to find the nonmetals. They are the right side of the periodic table. They are colored in yellow, that is towards the right of the zigzag division in the periodic table. Okay. Normally when we write a compound, a covalent compound, we need to know which element should we write first, because all of them are going to be nonmetals. So the name of the element further to the left in the periodic table, in other words closer to the metals, or lower in the same group, is usually written first. And then we use a prefix. A prefix is used to denote the number of atoms of each element in the compound. Now, in ionic compounds, we do not use any prefixes like mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. We don't use any of these prefixes in ionic compounds. But in covalent compounds, we do use them. But we don't use mono if you have only one element as your first element. Okay, mono is not used on the first element listed, however. Okay, a binary covalent compound is typically formed by the combination of two nonmetals. Some of these compounds are very common and have trivial names. For example, H2O is a covalent compound. We just say it water. But we're going to learn today what is the real name for H2O. Okay. For a binary covalent compound, the element with the lower group number in the periodic table is first in the name and formula. Its name remains unchanged. Just like when we were naming the metal name, we didn't change because that's the one went first. Similarly, in the naming of covalent compounds also, first element name we don't change. We're going to keep it as it is. The element that is second is named using the root with the suffix IDE. Similar to the way that we name ionic compounds, the second name we ended with "ide." Okay, but we don't use any numerical prefixes. But here we're going to be using numerical prefixes. Numerical prefixes indicate the number of atoms of each element present. But we're not going to name the first one. If it has 1, we don't call it as mono. That's the only difference. Now let's look at binary compounds, how we name them. The ending on the second element is changed to "ide." Now this one is carbon dioxide. CO2 is carbon dioxide. So you are very familiar with this, carbon dioxide. See, it's a covalent compound. First element remains as carbon, and then since there are two oxygens, we would say dioxide, carbon dioxide. And what about this? Carbon and oxygen. What do you name this one? How do you name this? This is carbon monoxide. Right? So for the second element, even if you have 1, you would have to say the prefix mono. But for the first element, you don't call mono. We don't say this one as monocarbon dioxide. It's just carbon dioxide. And this the second one is just carbon monoxide. We don't call it as monocarbon monoxide. Okay. And then this one, CCl4, is carbon tetrachloride. If the prefix ends with A or O and the name of the element begins with a vowel, the two successive vowels are often elided into one. We can name this one as dinitrogen. So you have to say di when you have 2. Dinitrogen pentaoxide, 5 oxygen, dinitrogen pentaoxide. We're going to put them together as dinitrogen pentoxide. Okay. And let's look at this problem. What is the formula of carbon disulfide? Now this is again covalent compound. Carbon is a nonmetal, sulfur is a nonmetal, so we will have to write carbon disulfide. So there are two sulfur, so carbon disulfide. What is the name of PCl5? So we have only one phosphorus, we would say just phosphorus, and there are 5 chlorines or 5 chlorides, we would say phosphorus pentachloride. Okay. And then give the name and formula of the compound whose molecules each consist of 2 nitrogen atoms and 4 oxygen atoms, N2O4. How would you name this one? There are 2 nitrogens, so you would say dinitrogen, and then there are 4 oxygens. How would you name it? Dinitrogen tetraoxide or tetroxide. Okay. Dinitrogen tetroxide. Recognizing incorrect names and formulas of binary covalent compounds. Explain what's wrong with the name or formula at the end of each statement and correct it. Now, SF4 is monosulfur pentafluoride. What's wrong with this one? Do we call monosulfur? No, if the first element is singular, we don't call mono. So that would be sulfur. Is it penta? Penta means for 5. So this has to be sulfur tetrafluoride instead of pentafluoride. And then the second one, dichlorine heptoxide. Dichlorine. So dichlorine is correct. Hepta for 7. Hepta is 7. So dichlorine heptoxide would be Cl2O7. What's written here is dichlorine hexaoxide or hexoxide. Okay. And then the next one, N2O3 is named as dinitrotrioxide. What's wrong in this one? Dinitro. We don't call nitro, we have to say the whole name for the nitrogen. It has to be dinitrogen trioxide. Okay. So what about this one? How do you name this H2O? What would be the name for this one? This is a molecular compound or a covalent compound between 2 nonmetals. How would you name H2O? That would be, how many hydrogens are there? 2. So how would you name it? Dihydrogen. How about oxygen? How would you name oxygen? If you have 1 oxygen in the second one, you would have to say mono. So dihydrogen monoxide. Now, hereafter, you are not going to drink water. What are you going to drink? Dihydrogen monoxide. So keep that in mind, okay? Okay, so that's how we name covalent compounds. And then we have, we're going to learn how to calculate the molar masses or molecular masses from chemical formulas. Normally, molecular mass is the sum of atomic masses, and we find the atomic masses from the periodic table. For the water molecule, molecular mass consists of 2 hydrogens, atomic mass of hydrogen plus 1 time atomic mass of oxygen. So mass of hydrogen from the periodic table 1.008 times 2 plus 1 time molar mass of oxygen 16. So 16 plus 2, 18.02. So by convention, we read masses of the periodic table to 4 significant figures. For ionic compounds, we refer to formula mass, since ionic compounds do not consist of molecules. Using the periodic table, calculate the molecular or formula mass of tetraphosphorus trisulfide. Now, in order to find the molar mass, we need to know how to write the formula. So, tetraphosphorus trisulfide, how do you write the name? or the formula, not the name, formula. Tetraphosphorus means how many phosphorus? 4. Trisulfide, tri means 3, S3, P4S3. And then you have to find out the molecular mass. So there are 4 phosphorus, 4 times phosphorus, plus 3 times the molar mass of sulfur. And then you're going to add those together. Okay, you can refer to the molar mass from the periodic table. P4S3, 4 times atomic mass of phosphorus, 3 times atomic mass of sulfur. Atomic mass of phosphorus 30.97 times 4, sulfur 32 times 3. When you add all these together to 20.09. And then the next one is ammonium nitrate. Now for the ammonium nitrate, we need to know again how to write the formula. So you can refer to the chart, polyatomic ion chart, and then if you refer it, you would see ammonium ion is NH4 plus 1 and nitrate is NO3 minus 1. Okay, so then you're going to do a crisscross to find out what's the formula, 1:1 ratio. So it would be NH4 NO3 ammonium nitrate. So this is the formula, and then in this formula there are 2 nitrogens and there are 4 hydrogens and there are 3 oxygens, and you need to find out their masses and then you add them together to find out the formula mass. 2 times the atomic mass of nitrogen, 2 times 14, 4 times the mass of hydrogen, and then 3 times the mass of oxygen. And these masses you can find from the periodic table. And when you add up, you're going to get the mass, formula mass of ammonium nitrate. It's not that hard. And then one more last thing about mixtures. There are 2 types of mixtures, heterogeneous mixtures and homogeneous. Heterogeneous has 1 or more visible boundaries between the components. For example, oil and water. It's a heterogeneous mixture. They don't mix together. Your salad dressing. Okay. Homogeneous mixture has no visible boundaries because the components are mixed as individual atoms, ions, and or molecules. For example, when you dissolve salt in water, sugar in water, so you can make a homogeneous mixture. Normally, we call a homogeneous mixture as a solution. Solutions in which water is a solvent are called aqueous solutions. We will be doing most of our reactions in aqueous solutions. Distinction between mixtures and compounds. Now, here is the first one is a physical mixture of sulfur and iron. Fe is the iron and SA can be separated using a magnet. So this is a physical mixture. So you can see sulfur and iron. And iron would be attracted to a magnet whereas sulfur would not. So this is a physical mixture. You can separate them. But between iron and sulfur, if you make a compound iron sulfide, FeS, you will not be able to separate them using a magnet, because iron and sulfur have reacted chemically to form the compound iron sulfide. The elements cannot be separated by physical means. Okay. So that concludes our chapter 2.